This is homework set 32 on quadratic functions. Question 1. For the equation y equals x squared plus 2x, the x-intercepts are already given, right? So we know those two x-intercepts. Now use the parabola tool and draw the rest of the graph. Now we need only one more point, and that would be the vertex. Then we can draw the graph through those 3 points. Now notice, on the x squared, the coefficient is positive, so this is going to open upward. So we just need to find this point down here, the vertex, and then we can make the sketch. So I'm going to rewrite the equation here. Y equals x squared plus 2x. Now, I'll write this like this. I'm going to complete the square. You remember how to do that? You take half of this coefficient, square it, and then add it to both sides. Well, we're kind of going to do that, but a little bit different. I'm going to have it, write it like this. X plus, now take half of that coefficient, square it. Now, before we go any further, what do you get when you actually do this? Square the first, multiply the two together, 1x, double it, 2x, and then square the last, plus 1. So you see, if I do this, what I'm really doing is I'm adding a 1 to that side. So I'm adding a 1 to that side. So to keep this thing balanced, what I'm going to do is, since I'm adding 1, what if I subtracted 1? That would just take me right back to that x plus 2x. So now I'm going to subtract 1. So here's what I did. I kind of completed the square. I wrote it as the quantity x, take half of that coefficient, and then square it. You get 1, but then to keep it balanced, I'll subtract 1. Now I can see the vertex here. The vertex, this is in vertex form. The vertex is the inside. The inside is the horizontal shift, and it does the opposite of what you think. If it's plus 1, it goes to the left. So the vertex here, the vertex goes to the left 1, and then the outside 1, that's the vertical, does exactly what you think, down 1. So I'm going to go to the left 1, down from 1, from the origin. So locate the origin right here, go to the left 1, down 1, and that looks reasonable, doesn't it? That looks reasonable because it's right between those two. Now I'll use the graphing tool. Well, I can't use the graphing tool on this, but I can graph this now. So I'll have to do it by hand. So I'll start here at the vertex, and then what I will do is I will go over 1, up 1, over 1, up 1, over 2, up 4, 1, 2, 3, 4. I'll put a point there. And then by symmetry, I'll get 1 over here. Now, as best you can, use that graphing tool and draw a graph through those points. Question 2, now we're going to graph this equation right here. And notice right up front that that coefficient of the squared term is negative. So this parabola is going to open downward. Now, all we have to do is find the vertex. Now, we're given 2 points already. We know it's going to open downward, so we know it's going to do something like this. So that vertex is going to be right between the 5 and the negative 3. I just don't know how high or where. But let's do it this way. Now, for the vertex, the x-coordinate is given by this form right here, negative b over 2a. That's part of the quadratic formula. So the x-coordinate is negative b over 2a. So let's write our formula, our equation here. Y equals negative x squared minus 8x minus 15. Now this is really y equals negative 1x squared minus 8x minus 15. So the general form is ax squared plus bx plus c. So if we identify here, a is negative 1, b is negative 8, and I don't need the c because the formula is just negative b over 2a. So let's do this. The x-coordinate is going to be, all right, negative b over 2a, so it's going to be negative, now b is negative 8 over 2 times a, which is negative 1. So how about 8 over 2? So it looks like it's at 4. All right, that's the x-coordinate. But you probably caught this before I did. It's not 4. What is this? 2 times negative 1 is negative 2. All right, negative 2. So how about now that the x-coordinate is at negative 4. All right, so the x-coordinate is at negative 4. Now I need the y-coordinate. So the y-coordinate, I'm going to get in because I know this. This is negative x squared minus 8x minus 15. So it's going to be y is equal to negative, now, negative 4 squared minus 8 times negative 4 minus 15. So y is equal to the negative of 16 plus 32 minus 15. Y is equal to, now negative 16 plus 32 is 16 minus 15. So the y-coordinate is a 1. So the vertex is here at negative 4 and 1. So locate that point, negative 4 and 1. Start at the origin. Negative 4 is over here, up 1. I've listed it here. So now we've got 3 points, and we're going to use that tool to draw our parabola. So using that tool, now I don't have that tool available to me here, but I'm going to draw this parabola as best I can by hand. Oh, I kind of missed that. See if I can redo that one. Smooth curve through here. I still missed it, for Pete's sakes. Come on now. Well, all right, the tool's going to make it look a lot better, but it's supposed to look something like that. Let's graph this equation, y equals negative x squared plus 9. Now, I'm going to use this formula for the x component. The x component is going to be negative b over 2a. Now, here's our equation. Y is equal to negative x squared plus 9. But if I write it complete, it would be negative x squared plus 0x plus 9, right? 0x is 0, so it typically doesn't show up. Now, in this case, a is negative 1, b is 0, c is 9, but I don't need the c here. So what's the x-coordinate? The opposite of b. Now, b is 0 over 2 times a is negative 1. This is just going to be 0. So the x-coordinate is 0. Now, I have to get the y-coordinate. Okay, so to get y, just use the formula. Y is equal to negative x squared plus 9. I get y is equal to negative 0 squared plus 9. So y is equal to 9. So the vertex is here at 0, 9. Locate that point. Now if I locate that point 0, 9, 0, up here at 9, there's 8. 9 would be right here. Now let's see if this makes any sense. First of all, this coefficient is negative, so the parabola opens downward. And sure enough, this parabola is going to open downward. So I just drew a few more points in here. Now, as best you can, use that graphing tool and pass a curve, use the curve tool and pass a curve through those points. You'll have 3 points. It should look like that. Now, this equation is already in vertex form. So I'm going to write the vertex is located at, look at the inside for the horizontal shift, the outside for the vertical shift. Now, the inside does the opposite of what I think. I would think plus 1 should go to the right, but it does the opposite, so it goes to the left. So we're going to start the origin, go to the left 1, and then the outside, that'll tell us the horizontal shift, just exactly what it says, plus 3, this is going to go up 3. So I'm going to go start at the origin, go to the left 1, up 3, and put a point. And that point is going to be at the vertex. Now, let's see. It says fill in the blanks about the vertex and any intercepts. Okay, now I don't show it on here, but they're asking us for the intercepts. Well, look, this coefficient out here is a positive. So this parabola is going to open upward. So it's not going to intercept the x-axis. So we will get no x-intercepts. Okay, so there are no x-intercepts. But we can do what we can to get the y-intercept. Get the y-intercept. All right, now the y-intercept, this is going to be where x is equal to 0, right? When x is 0, we're going to get where we cross the y-axis. So let's just let x equal 0 in here. So we'll get y is, I'll write the equation here. y is equal to 2 times the quantity x plus 1 squared plus 3. Okay, let x equal 0. We'll get 2 times 0 plus 1 squared plus 3. 2 times 1, all right, I'm just going to write it. 1 squared is 1. All right, so 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. All right, so there is the y-intercept. So I'm going to be here at 5, right there. Now this is the vertex, right here. And I know that the curve is symmetric around the vertex. So this says if I go to the right 1, I'd go up 2. So now go to the left 1, up 2. So to the left 1, up 2 puts me over here. Now that's pretty tight, but do the best you can, use that tool to get your parabola through those 3 points. Question 5. Find the vertex and any convenient point to sketch the graph of the following function. All right, so here's what I'm going to do. I notice this is negative, so I know it opens downward. Now I'm going to use the x-coordinate. All right, so I will get this. The x-coordinate is negative b over 2a, and our equation is y equals negative x squared minus 4x plus 1. So a is equal to negative 1. B is equal to negative 4. So the x-coordinate is negative b, negative 4, over 2 times negative 1. So this looks familiar. Well, a little bit different than the first one, I guess. This is 4 over negative 2, so the x-coordinate is negative 2. All right, so let's locate negative 2 on the, well, I don't want to do that yet. Now I need to get y, all right? So I know it crosses here at negative 2 someplace. All right, let's just get y. So the plan is now to get y, and we know that y is equal to negative x squared minus 4x plus 1. And if x is negative 2, I'll get y is equal to negative 2 squared minus 4 times negative 2 plus 1. So I'll get y equals, now negative 2 squared is 4, I'll get negative 4, and then plus 8 plus 1. Okay, negative 4 plus 8 is 4 plus 1, y is 5. All right, so the vertex is going to be here at negative 2, I found the x-coordinate, negative 2, and the corresponding y-coordinate is 5. So it's going to be at negative 2 and 5. Let's plot that point. So negative 2 up 5. All right, I'll plot that point. Negative 2 up 5. Now, I know this opens downward, and I know what parabolas do. What they do is this. It opens downward. So I'm going to go over 1, square it, down 1. Over 2, down 4, right, square it. It says square. All right, so here's what I'm going to do. Over 1, to the left 1, down 1, to the right 1, down 1. Now to the left 2, 1, 2, down 4, square it. 1, 2, 3, 4, that would put me here. And then to the right 2, down 4 puts me here. And then let's do one more. If I go to the left 3, all right, I'm here. If I go to the left 3, I'd go down, square it, 9, 5, 6, 7, 8, 9. That puts me way down here. All right, so 5, 6, 7, 8, 9. I think it's here if I counted right. And then symmetry over here. All right, so best you can, use that tool and get a curve through those points. There we go. And that finishes this part of homework set 32.